All right, so we're going to talk about logarithmic functions. So to introduce this section, we're going to start with a problem. Solve 3 to the x equal to 9. Well, 3 to the x equal to 9 is not too bad, okay? 3 to the x equal to 9. Get the same base for each side, and then set the exponents equal to each other. And so now we have x equal to 2, right? Well, what if instead of 3 to the x, right, because this one's not too bad. I know if I plug in 3 squared, I get 9. That solves it. But what if instead the question was solve 2 to the x equals 9, right? 2 to the x equals 9. Well, why is this one challenging? Well, if you think about it, if I plug in, how can I rewrite 9 to be a power of 2, right? Because 9 is just 3 squared. And then, now all of a sudden I've got a base of 2 over here and a base of 3 over there. I can't use my trick that I've been using up to this point. I could try to approximate this. I mean, if I put 2 cubed, what's that give me? That gives me 8. That's close, but it's not big enough. If I put 2 to the 4th, I get 16. And so that's way too big. So it's somewhere between 3 and 4. Okay? So, maybe, you can approximate and play that game. 2 to the 3.1. What is that equal to? Well, I mean, we could see 2 to the, let me do 2 to the 3.1. That's 8.57. Maybe 2 raised to the 3.3. What does that do? Okay, that's a little too big. That's a little too big. 2 raised to the 3.2. All right, now we're getting closer to 9, right? So maybe 2 raised to the, 3.18 maybe? I don't know. Okay, so now we're getting closer, right? So we're getting closer to a value, but that's not really an algebraic way to do it, right? So we're getting close to 9, but that's still not very good. Okay, so we need to figure out a way to get the exact answer here. And the way we do this is through logarithms, all right? So first we need to talk about inverse. So inverse function for a to the x. So say you have a function a to the x. So if you have some y equal a to the x, then the inverse function is going to be the log base a of x. That's the inverse function. So how do these relate? Y equals 2 to the x, so we're just going to pick an a equal to 2 here so we don't lose generality. And this is the same as x equals log 2y, okay? So the thing to remember here is that the answer to a log is the exponent. The answer to a log is the exponent. So the answer to this logarithm is the exponent. The exponent here is x. So the answer to the log question, log 2 of y, is equal to your exponent here, okay? So what I want you to do is I want you to think of the log function and the exponential function as inverses of each other, okay? So it's like if I had the x squared function, how would I get rid of the x squared? I'd take the square root of it, and that gets me my x, right? Now, technically, you get that plus or minus x, but who's counting, right? And same thing if I have the square root of x, to get rid of the square root of x, the inverse, I square it, right? and you get the x again, okay? So it's the same thing with a log, okay? So if I want to turn this y equals 2 to the x into a log, okay, what base do I have here? Well, this base is a base 2. So what I'm going to do is I'm going to log base 2 both sides, okay? And when I log base 2 both sides, what do I get? I get log base 2 of y equals, and what happens? I get log base 2 of 2, which cancels. It's like the logarithm cancels out that base, okay? And all I have left is my x. So that's how we can go from this over here to that. Now, to get rid of a logarithm, all right, so say I started with x equals log base 2 of y. Say I wanted to get rid of that log base 2. Well, the way you get rid of a log base 2 is you raise both sides. So we have a base 2 base here. And so that cancels your log base 2 with the base 2 here. And so you get y equals to 2 to the x. So not only does it work going from one to the other, it works from starting here and going back over this way. That's how inverses work for each other, okay? So the question becomes, going back to our answer here, how do we find x, okay? The question is, to what exponent must 2 be raised to produce 9? That's the question, right? So going back to our example here, I had 2 to the x equal to 9. And if I want to convert this to a log, what do? I log base 2 both sides. Because if I log base 2 both sides, that cancels, and I have x equals log base 2 of 9. Now the question is that this answers is, to what exponent must 2 be raised to produce 9? Okay? So this answer can be found with your calculator. All right, if you've got one of the more advanced calculators, okay, you hit the log button. All right, now mine isn't one of the advanced calculators, so I'm going to have to use a trick here. So if you've got an advanced one, you're going to have it where you can type in the base, okay? If you have one of the calculator like mine, then you're going to have to do what's called a change of base rule. So to calculate this, I take the log of 9, and then I divide by the log of 2. Okay, and I hit enter, and I get 3.1699. So it's like 3.17. Okay, this is the change of base rule. To get the log of base 2 of 9, I take the log of 9 divided by the log of 2. Okay, so change of base formula is log base A of B equals log B over log A. That's the change of base formula. So you can type this in your calculator to get a decimal approximation. So what did we say that was? It was like, oh, let me quit out of that. 3.167 maybe. Okay. All right. So, wait, was that what it was? 3.169. So this ends up being 3.17. Okay. Now, what I want to do is I want to show you how to write equations in logarithmic terms, okay? And so we're going to do that now that we've done an introduction into logarithmic functions. We're going to work through writing in logarithmic terms. So write the following equations in log form. Okay, log form, logarithmic terms. Alright, so first one. So first we start in exponential form. 5 cubed equals 125. How do I write this in log terms? All I got to do is I got to log it. All right, what's my base here? The base is 5. Okay, so I'm going to log 5 both sides. So I'm going to log base 5, 5 to the 3, and then I log base 5. If I do something on one side, I got to do it on the other side. 125, right? So what happens here? The log base 5 of 5 cancel, and I just have 3 equals log base 5 of 125. Okay? And that is my logarithmic form. So this right here is exponential form. This is log form. Okay, so we're trying to put an exponential form into a log form. Let's do another one. 4 squared equals 16. Let's put it into log form. How do I do that? I look at the base. What's my base? My base here is 4. So what I'm going to do is I'm going to log 4 both sides. So I log 4 and I log 4. Those cancel and I get 2 equals log 4 of 16. When you think of logs and exponentials, think of a log as the anti-exponential. It's the opposite. So the opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of exponential is logarithmic. So we're just doing the opposite here. Okay? Let me do another one. 2 to the x equals 9. Let's do that. We already know what that is, don't we? This log 2 both sides to get rid of that base 2 right there. Log 2, 9 cancels. X is log base 2 of 9. One last problem, make sure we got it. 1/2 raised to the x equals y minus 2. Okay, so what I want to do is I want to put it into log form. What's my base here? My base is 1/2, so I'm going to do log 1/2, okay, of what? 1/2 to the x equals what? Log 1/2, and then what goes in my argument? All of it, y minus 2, okay? So the log 1/2 cancels, so I get x equals log 1/2 of y minus 2. All right, that is the log form, okay? What if instead of being in the log form, instead of being in log, I want to write it in exponential? So write the equation in exponential form. Exponential form. So what does exponential form look like? Okay, well, say I start in my log form. Log base 7, 49 equals 2. That's my log form. How do I get rid of a log? Well, the inverse of the log is the exponential. My base here is a base of 7. That's not a highlighter. My base is 7. So I'm going to raise both sides. So I have a 7 here, and I do the same thing over here. And what happens? The 7 raised to the log 7 cancel, and I get 49, whatever's left in that argument, right? equals 7 squared. This is the exponential form. When you look at this, does, oh, that's an ugly R. When you look at that, does this equal, is this cool? Yeah, 49 is equal to 7 squared? Absolutely. That's the exponential form. All right, let's try another one. Okay, so log base 16 of 4 equals 1/2. How does this work? Well, look here, I see my base is 16. The opposite of a log is an exponent or exponential, so I'm going to raise this. So 16 on both sides, cancel. I get 4 equals 16 to the 1/2. Now, if you guys remember, the exponent, which is a rational number, we can use that rider and the horsey trick, right? This thing, if you've forgotten, it's square root of 16. Why do we know it's a square root? Well, the rider and the horsey. The rider goes on top. The rider goes in the house, right? The horsey goes underneath. So the rider's on top of the horsey, but then the horsey goes out in the barn. Okay, so outside the house. So this is the square root of 16, which we know equals 4. So we can leave it in this form here, 4 equals 16 to the 1/2. That's exponential form. Okay, so that's what we're looking for. Now, one more just to make sure. Log of 100 equals y. Uh-oh, what's different about this one? Well, when I look at this, I don't see a base anywhere. When there's no base here, it's understood to be base 10. So if there's no number there, it's just log, then we use the common log, which is base 10. Okay, so how do I fix a common log, base 10? I raise both sides. I have 10 here and 10 here. Those cancel, and I get 100 equals 10 to the y. Okay, this equation is easier to solve than log 100 equal y. Okay, unless you have a calculator, right? All right, one more thing that will help out just to make sure we've got converting to log to exponential. Log base x of t equals u. Okay, what's my base here? My base is x, so I raise both sides to, I have an x here, those cancel, I get t equals x raised to the u. Okay, so that's the exponential form. This is the log form. Okay, so hopefully that illustrates it. Now we talked about the common log. There's one more log that you're going to run into, and it's called the natural log. The natural log base is e. Okay, so the base here is e. And what the natural log base looks like, so it's y equals log base e of x, which is written as ln x. Okay, now ln x, its base is e, so how do we get rid of a base e? Raise both sides, and so you get, that cancels, you get x equals e to the y. So the inverse of ln x is what? E to the x. Okay, so you've seen these keys before. Okay, so when you go look at your calculator, you look down on the left side. Okay, you'll see the x2 button. That's a square button, like that's how you square something. But then if you hit the second and then the square button, you see how those are inverses of each other. You'll see that. Same thing works with log. Okay, you got log of whatever. But then what else? If you do the second thing, you get 10 to the something, right? So this is a way to help you cheat, okay? If you're having trouble remembering who's the inverse of what, log x here, whatever, who cares? And then second, and I hit that log, that same key again, the inverse of the log x is 10 to the x. Same with my ln right underneath that. Okay, that's log ln whatever. And then the inverse, I do the second and I hit the ln key and I see right there it's e to the x. So that kind of tells you, what the inverse. I wonder what x is equal to here. Oh, x is 9.995. Okay, whatever. All right, so these are the inverses of each other here. Okay, so other facts that might be useful for you. So other useful facts. If I raise something to the 0 power, what does it equal? It equals 1. So if I did the log form here, okay, how do I get rid of the base a? I log a both sides. Log a to the 0 equals log a 1. So those cancel. So I get 0 equals log base a of 1. So what is this telling me? If I'm taking the log of 1, no matter what my base is, the answer is going to be 0, okay? Remember, you're asking yourself the question, to what exponent must I raise a to produce 1, okay? Well, if you think about any number, I raise it and I get 1, whatever that number is, okay? The only way that's going to happen is if x is equal to 0 here. So that's why we get that going on there for positive a, okay? Another fact is a to the 1 equals a, which seems pretty obvious. But, the log form, maybe not so much. I log a both sides. And what do I get? Log a, those cancel. So I get 1 equals the log base a of a. Now this is very important to us. We've been using this trick the whole time without knowing it. What this is telling me is that if I want to get rid of a base a, all I have to do is log the base, and then it cancels it out and I get 1. So like when I was looking, so when I was looking at these exponential forms up here, and all I wanted to do was get rid of that 4, once I log 4, what this thing right here, that canceled to get me 1, and I was left with just the 2 there. Okay, so that's what's going on. All right, that's what's going on. Okay. I always think of my logs as exponents, okay? Because the answer to a logarithm is an exponent. That's kind of how I think about it. So our trick, this is our trick. It's a really handy trick, right? So it's a good way to think about it. So this is how we cancel logs. Okay, this is how we cancel our logs. All right. Now, that's one way to do it. Another way, you got the a to the x and you want to get the x out. All you got to do is log a both sides to get your x. But if you already have a log a and you want to get x, what do you have to do? You have to a it to cancel. Okay, so these two tricks here, as long as you remember that the inverse, right? The inverse of the exponential is the log, and the inverse of the log is the exponential, then you can get this. Okay, so those are my tricks. All right, guys.